It's nice to just sit and chat, you know?
It is, and there are many things we can chat about.
It's nice to not have to have.
But,
Well, most of the time it's just you chatting. We don't get to chat.
okay,
Hey, there's a
I
lot
had to
of
get
time.
paid to chat.
We don't.
I know.
We don't get paid at all.
I get, you do. You get paid in future revenue that you're going to earn by having a good
Is it
education.
question time?
But I mean, am I really
Can
gonna?
we have questions?
Yeah, we are going to answer questions, beyond just what Hunter wants to chit chat about.
Oh, let me get a pencil.
Number 3 on the lab.
Yeah,
Number 3 on the lab.
let me talk about that.
Oh, hey, we talked about that during law course.
Oh, wow.
Oh, yeah.
Okay.
Did we ever actually do it?
So, what? Did you think you not had to do the question?
No. I meant like, we attempted it and then like, we just skipped it and I didn't know if we went back. and
That's what I did too.
Okay, all
I
right.
just put a check mark.
So, visualize this. Visualize. Okay?
Oh, yeah.
So, you had the metal cube, right? That you lowered down into the water. Now, as more and more and more of the block got below the water level, what happened to the buoyant force? Got bigger. Now, did you directly measure the buoyant force?
No.
No, but what did you notice? No, the net force was 0 all the time. No,
AJ.
The scale got less.
yeah, so what was the scale measuring? Tension, right? So there's a couple of explanations that could happen. Number one, as it got deeper and deeper and deeper into it, water acted as like a deflector of the gravitational force. Gravity wasn't pulling it down as strongly because of the water, and then, because the water was acting like a gravity insulator, and therefore the string didn't have to provide as much upward force. It's an option, okay? I'm not saying it's right, but that's an option, okay? So as it got deeper, gravity got weaker, therefore the upward force didn't have to be as much. That's an option. I don't recommend it, but that's an option. So, in reality, as you got deeper and deeper and deeper, what happened to your buoyant force? It got bigger. Because your buoyant force is always what? What's your buoyant force always equal to?
Rho VG.
Well, the weight of the fluid that's displaced, right? In this case, it's going to be rho VG. What's this rho going to be? The steel, the aluminum, or the water, or the fluid in general? The fluid, okay? Now, so obviously as the volume of the fluid displaced gets bigger, what happens to your buoyant force? It gets bigger. Therefore, there's less tension on the string, because no matter what, your net force is going to be 0. So if you look at this, your Fg isn't going to change. That's a fixed value. Okay, that's it. That's a fixed value. So what was the weight of like that aluminum, let's go with that steel, what was the iron block's weight just without any water at all? It should be around like 2.55, something like that. 2.55? Okay. So 2.55, that number isn't going to change. Okay? That's it. It's 2.55 newtons. Now, when you submerge this thing halfway, what was the reading on the scale? But like, what was the actual reading? So when that iron block was submerged halfway, what was the tension reading?
2.5
2.5?
to 2.35.
Okay, well let's go 2.5. Okay, so if this thing normally weighs 2.55 newtons, and the reading on the tension dropped to 2.5, what was the value of the buoyant force? Yeah, it's the difference between those two. So as the difference, as you lowered it deeper and deeper and deeper, the buoyant force got bigger and bigger and bigger, so the tension in the string became smaller and smaller and smaller. Okay? Good with that idea.
Did that answer our question?
No.
Okay.
Yeah.
It didn't.
I thought that's what you were getting at. I was
Okay.
like, that didn't help.
But here's my question. So if you were to replace with a cylinder, right? Okay, if you were to replace it with a cylinder, you need this volume, right? Okay? Because it's the volume of the fluid that's displaced. So here's the deal. So if you look at this, you have an aluminum cylinder with a diameter of 2 centimeters. So if you know the diameter, okay, right, what can you find?
Radius.
If you know the radius, you can find the area of the cylinder, right? Then if you know the height, you can find the volume. So if you can find the volume of this cylinder at the 3 centimeter mark, and compare that to the volume of your cube at the 3 centimeter mark, whichever one has the greater volume is going to have the greater buoyant force.
Now, how would you find the volume though?
Of the cube.
How, do you know the cross-sectional area at the bottom of the cube?
I don't know all the ways.
Yes, you do. Look. The first thing that you were supposed to do was to find these 2 dimensions of the cube. So here's the hook. You were supposed to find these 2 dimensions. Let me see your paper.
That does not.
I don't know what you're trying to say.
What's the equation for the volume?
Look, you have the area written down right here. That's the area of the bottom.
Yeah.
There's not.
Of the cube.
Okay, and then what we do that?
Then multiply that by a depth of 0.03 meters, which is 3 centimeters. Okay? And then you can find that volume. Then do the same thing with the cylinder.
What's the area?
Okay?
Yeah, what's the area of the cylinder?
What's the equation?
How do you find the area of a round circular
Pi r
object?
squared.
Pi r squared. So pi r
Times height.
squared will get you the area, right?
Right.
Then multiply that by the depth of 3
No,
centimeters.
that's all you have to do.
Yeah.
I thought when we were reading that, it was like.
Oh, we went on Google to find the area for that. And it
The
said,
area of what?
0.01
of the
meters?
cylinder.
You're seriously.
No, I swear.
I
It
swear.
said,
You are serious.
no,
We're about to give you high school diplomas,
no. And it said,
Is
and I
this
guess that
3
you were towards
centimeters?
the top of the
It's
class,
3, so it's 3.03?
he said,
and you had to go to Google to find the area of a circle.
no,
The
of the
cylinder.
cylinder. It's not a circle.
We know the
But
area of a
it's,
circle.
look, it's cross-sectional area times height.
Okay, what does cross-sectional mean?
Hey, that's a fair
I
question.
can't be the
That's
only
a
one
fair
in this class
question.
that's not asking that
Okay.
question.
Cross-sectional area would be like the area of the end of the marker. That would be the cross-sectional area.
Did you
Then
get?
you multiply that by
Yes, you did.
the height.
So all I have to do is just find the area of the bottom part of it,
Oh.
like this, like.
No,
Yeah.
cut it
Which one are
down.
you? Oh, that's the second
Yeah,
one.
And then I just
Gotcha.
multiply by how high I
Gotcha.
want it.
Yes.
Okay, that makes sense. I wasn't aware of that.
We went on, for cylinder, it said to find the area of the 3 circles,
And then-
find the circumference of the circles, and do the circumference times the height of the cylinder.
Yeah.
That would be surface area, but this isn't surface
So you
area.
Googled it wrong.
Oh, you Googled the wrong
You
answer.
Googled it wrong, that's not
The
our
fact that you had to Google it at
I
all.
was the only one that came here that said to Google it, so.
Yes, he was.
We
That's what I was gonna do, and then Grant was like, I guess I'll have to Google it.
So can you
That
give
seems
us
like a
an
very,
inch on
very
which one
different
would be
number.
bigger? Please.
Categorically. I refuse.
I need
Breathe,
one.
Connor, breathe.
Oh my gosh, that was good.
Look, and if you really want to shortcut the process, since you're multiplying
So
both of these
the-
by 3 centimeters, the one that has the bigger area is going to be the one that's going to have the bigger volume at 3 centimeters.
Volume.
I'm gonna do that now.
So that's just pi r squared times h. Is
To get the volume submerged
So
in
you get the
the
area of the aluminum base, is
pi
0.03 meters.
0.01
That's such a different number.
Oh, and we're
Like, I
about to
got-
give you all
I got the
diplomas and say,
cylinder.
and tell the world that we've given you a quality education.
Okay, well, the area of iron is, oh wait, I don't need that.
It doesn't matter
Yeah,
if
I
you're
do.
multiplying it by the same thing.
Now, does it matter at all whether it's aluminum, copper, or iron? Did I even have to give you what the material was made out of?
So then it's
No, the only thing
0.009.
that you had to know was that it was more dense than water so it would actually sink,
Yeah.
okay? What it's made out of doesn't matter. And that was the whole point of this lab, was that these cubes were specifically made for this lab. And so whether it's aluminum or iron, if you put them both
Oh, it
below
is.
the water,
There's a cube
even though the
beside
iron
it.
is much more dense, they're both gonna have the same buoyant force. Because they're both displacing the same volume of water.
Yeah, because this is to the -6.
So this area of the cylinder, that's just pi, right? Since radius is 1.
No, it's 0.01 squared.
It's 1 centimeter, Skippy. You have to change it into meters.
Makes sense.
Thanks.
Yeah, I got it.
Can you give me an ish about which one is greater?
Yeah, are you gonna get it?
One of the two. Kendra, did you end up getting it?
Yes.
Does it
I
start
was
with the
doing
C?
something
The
really
cylinder's
dumb.
smaller, okay.
I'm not going to even answer
Started with
that.
C.
Can we talk about number 10 on the yellow?
Yeah.
Okay, thank you. Is this what your graphic ends up looking like?
Is this with the steel hole?
Yes, and I got halfway through it and then like,
The same, because the density of the
it didn't make sense.
Okay.
I didn't know what density to use for
Oh, on 8, I also can't say.
one of them.
Yeah, no, yeah, they both change, FG and FB both change. But the density is the same.
Oh no, no. About the initial density. Do you want to? I'm gonna just go turn this one in because this is different.
I actually kind of, not really, because I had John it, so.
I feel like you just put batteries in that.
I did just yesterday.
I'm gonna get you some batteries for
No.
Christmas, Mr. Brown.
I do, triple A.
Really though,
I
do
do
you want to do
batteries.
Secret Santa?
I'm buying
I really want to. Oh god, I just pulled off my name tag. I got like crap on it.
Yeah, let me get everyone to give like -6 cents and then make it.
I'll give you some wood.
I used all of my last paycheck for Secret Santa gifts. Between at work and school and like gifts for my family. All of it.
Have you ever wore that to school? I would honestly burn it. Like, I would start the jersey on fire while.
Did you do that one?
Yeah, you're right.
You were Cap. Was not actually. Dude.
Okay.
Hating on Cap.
So,
Oh, I never stopped it.
let's talk.
You didn't stop it?
So let's talk.
Okay, number 10.
So, here's this piece of steel that you're gonna lift up out of the water.
I got that.
So, what are the 3 forces acting on the steel?
FG,
Gravity's
gravity.
acting down. Your buoyant force is acting up.
And tension, acting up.
And you have your tension, which is also acting
Up.
up. Okay?
A is done.
So by virtue of the fact that you have to supply some tension to it, okay? What's bigger, the downward force of gravity or the buoyant force?
Gravity.
Gravity. So right away I know this is going to be bigger than this, right?
Got that.
So basically the tension has to make up the difference.
Okay.
So if this was like 5,000 newtons and the buoyant force was 3,000 newtons, the tension would have to be 2,000, so that everything would add up to equal to 0. So if I can find these 2 values, I can find the difference between these 2 is going to be my tension. Does that make sense?
Got that.
Okay.
Got that.
So my tension is going to equal Fg minus Fb. True? So what do I need to calculate the gravitational pull?
Density, velocity.
No.
MG.
Yeah,
So
but
you
which
just-
mass, the water or the steel?
That's all you needed to do for MG or FG? Dang it.
It's just the mass of the steel times G, right?
Okay,
Yeah,
then
that's-
that was where I was getting confused.
That's 176,000.
17 weeks in and we don't know how to find the way.
Well,
Diploma.
True.
Can't believe we're getting diplomas, guys.
Are we?
I haven't given them to you yet.
Oh, Mr.
I don't need
Taylor.
this.
I'll give it to you.
Yeah, I'm sure she won't deny you that. Now, here's the deal with the buoyant force. What's your buoyant force? What do you need to find the buoyant force?
You need the volume of the object.
Rho.
I need the volume of the steel. I need the density
That
of
makes so much sense. I was trying to figure out
water,
what FG
and
was,
then
and I could not
G,
figure it out.
right? But do you have the volume of the steel?
No.
No.
No, but you have the mass of the steel and you can look up the density and you can find the volume of the steel.
Where?
Well, how does that work?
Well, you see, it's short.
No, I've got some of my notes, never mind.
Okay, look,
Mass times
density is mass
Is it
divided
seawater
by
or fresh water?
volume, right?
equals mass divided by volume.
You know the mass and you know the density.
So,
So solve for the volume.
so we want mass divided by density.
Yes.
Okay, the density of steel. That's what we want.
Mass of steel.
So if you're actually like a sea turtle, this answer to huh? No, I mean, it's very relevant to sea turtles. If you look at what happens to your answer on 10E, once it clears the water, what happens to the tension in the cable?
Completely.
It goes up a lot, right? Because you lost your buoyant force. So the same thing happens with sea turtles. And sea turtles swim in the ocean, they're basically neutrally buoyant, okay? Well, but they have to go on land or up on the beach to lay their eggs. Well, as soon as they leave the water, what do they lose? They lose their buoyant force, right? So now, without that buoyant force, their flippers work great to move around in the water, not so good climbing on a beach. So this is why it's such a struggle for them to get from the water up to the beach, to dig in the sand, to lay their eggs, to then go back down, back to the water.
So why did they
Because
lay their
they've
eggs on
completely lost their buoyant force.
Why did they
Baby
their
sea
eggs
turtles
on-
on like the Animal Planet, there's
Well, I know about lots.
Yeah,
You know,
most
that's one of
babies
those
are.
mysteries that I have yet
Yes.
to
Do you
know.
want us to transit or can we keep it for the studying tonight?
If you would hold on to it and hand it in tomorrow, you can.
Okay, I'll probably do it.
One more quick question.
Okay,
On the lab,
yes?
when it's the procedure number 7, determine the initial density of the fluid. It's, I didn't know what that meant.
What do you think we're gonna do for this?
I did my homework.
What about number 7? What about,
It says determine the pO of the fluid.
determine what?
The initial density, doesn't it?
Yeah, and that's it, based upon the slope of the line.
So it don't have to.
Yeah, that's, you've
Okay.
already done it when you find the slope of the line. Okay, yes?
This is relevant to the final. Will you give us like a hint on what the lab is gonna be?
It involves razor blades and fire.
That's not a good hint.
That's not a good thing.
Okay.
Hey, cheese, easy. Start calling you fondue, okay? So the short version is that a marble's gonna swing down, it's gonna get cut by a razor blade, it's gonna turn into a projectile. You have to drive an equation to figure out where it's gonna land and then measure and predict, and your grade is based upon how close it lands to the target.
Yeah, that's what my brother did. Okay.
It's an absolute classic.
The stroke
Okay.
strings.
Sounds like an
Let's just say
accident.
hypothetically,
Hypothetically,
I don't know how to tie knots.
Are you
Do it
doing?
for me.
Are you gonna do?
Because that's a real issue.
hypothetically, cheese to, we can overcome.
Okay.
Are you gonna do whoever gets closest gets extra credit?
Yes.
Close to the bullseye.
But now, there's 24 of you, okay? There will be no more than 4 in a group.
Yeah.
So I'm just throwing that out there now, so if you
Yeah.
all want to start to parlay how this deal plays out.
4 in a group.
Yeah.
4 in a group, 6 groups of 4. If you want a smaller group, that's fine, we can go to 7.
How about we do?
Yeah.
There will be, the maximum size group, listen to me, is 4.
We've kind of been doing 6 all year, so.
Well, really? I don't know, we don't care.
You get
Yes, yes, I will.
On this.
Yes, I will.
All right,
We're gonna get it too. We gotta start.
anything else?
My face.
Got it.
Oh, wait.
Okay?
Yes.
All right. Your percentage that's submerged on number 9 should be around the legal drinking age. Okay?
That's not close enough.
On 9E. Okay?
Okay.
You have a lot of things.
Anyway, if you want to hold on to this buoyancy assignment and hand it in tomorrow, that's cool. If you want to hold on to the lab and hand it in tomorrow, that's cool.
Do that.
Okay? But I want them tomorrow, if you're not going to hand them in today. If you hand them in today, especially that buoyancy assignment, I will get it graded and it will be available before school if you want to come and pick it up before school, if you hand it in.
I'm getting the same.
Okay?
Did you? Close enough. That is, yeah, that's close enough. Once the tension on the table, shoot, once it's completely out of the water,
Oh my god.
what do you do for that? You put an air instead of water.
Terrible.
Let me put it this way. One of the questions on the review goes through O.
Oh?
Like A through O.
Dude, that's on the final review or the test review?
For the test tomorrow. It's just a gas that we're taking through different processes. So it just builds off of one another.
Still, you were able to come up with questions A through O?
Yeah, and I stopped there.
Oh my lord. That's gotta be a record of some sort. I've never do a problem where it goes to O. Oh, you only have 4 problems on the side.
I can break them up into different questions if you want.
That's all you're doing.
Yeah, so it's like, oh, it's a one question final. Cool.
Oh, this is like,
1 through 100.
Yeah.
did you get like a really, really big number on
Alright,
me?
turn in the lab.
Yeah, that's about right.
Do you want the pre-lab with lab?
Everything the same.
Huh?
Instead of
Do you want the
multiplying
pre-lab?
by 1,000
It's
more
1,000.
water.
Yes.
1.5 per times.
Okay.
Fit.
The salt, the seawater is 1,025. So you use that.
So you take 1,025 times 2.31 times 19.
Alrighty.
It should be,
And so then you would subtract that.
Okay, it was 150.
yeah.
And then you get your answer to B or C.
Okay, so let's talk big ideas that are going to be on this test tomorrow. Okay? There will be the advanced energy stuff where it is rolling, where it has both translational.
No.
Sorry. I'm freaking out now.
This
Yes.
is tomorrow?
I remember.
I really
Translational and rotational, right?
That was perfect.
This is open though, right?
Yeah, open no.
That's funny.
Wait, so our
I'll
written
give
final
that
is
the highest grade you can get is a 70%.
On what?
What?
No, I'm kidding.
raise it up to a
85 and we have
75
to
and you got a B. Alright. Let's just grade it on bell curve. I'll buy that.
Okay, if we're gonna do
What?
that,
That's bad. Why would you?
okay, then realistically, then a 90% might not be an A. Because if I grade it on the bell curve and you all do really well, if you want to do it that way, then we're gonna do it that way.
No, Ellie is really good at this.
How do you do the bell curve?
Let's grade it on by the amount of dumb
There's
stuff
like
you
a
say
stripper
during
who are
class.
really good at this.
Let's grade it out of
Okay.
how many I get right.
You gotta watch out for that.
Rollins is the
I'm gonna
benchmark.
be a-
Whatever you get is 100%.
Yep. So everybody.
It's like when-
gets
it's like when the
gets
teacher
extra
takes the
credit,
test.
And I get 100. It's a win-win for everyone.
Oh, Brooklyn wants hers to be the baseline.
Alright, everybody have like 100.
Yeah, Merry
We
Christmas.
would be set.
We'd be set.
Okay.
The struggle train now
Anyway,
is
I
set.
can't do that ethically, morally, or any way in between. So,
Hey, you'd still take it.
okay.
What? Like 10.
Now, when something is rolling, like for example, this ping pong ball as it rolls, what type of energy does it have?
Translation.
It has rotational kinetic energy and
chapter.
translational. So the total energy is going to be the sum of those two. How do you calculate KR?
Somewhere on the
I omega, not omegas. You know what I'm saying?
1/2 I omega squared
Didn't we already take this test?
plus 1/2
MV squared.
This is like last unit. I don't
Why are we using this?
Didn't we already take a test over this?
I thought we did this.
It was just, all you took the test over was just like springs and simple stuff, not over this stuff. Okay?
you just like omit this part of the test.
Come on. I'm hanging on by a thread here.
But it'll count. It'll count against.
You're right, but I'm telling you, you don't have to do this part of the test.
Have you ever had kids
I'm just waiting
crying
for the
in
final
your
and it
test?
tells
If I
you.
cried,
Like mental breakdown, they couldn't handle it anymore.
Occasionally.
I bet you, yeah.
tomorrow I'm gonna just cry and
What do
see
you
what
have to
happens.
substitute in for I?
Moment of inertia.
Yeah, whatever that calculation is,
Whatever this thing is.
could be MR squared, could be 1/2 MR squared. This is gonna be dependent upon what that object is, whatever that calculation is for moment of inertia. So, now, here's the kicker though. What can you substitute in for omega?
The conversion.
Yeah,
It's like
because
V
V
over
equals
R.
R omega, so a lot of times it's handy for that omega if you put in V squared over R squared. So then what you see a lot of times is that this is going to involve R squareds. The R squareds will cancel out, it actually makes it simpler. So one of the things you want to be able to do for this omega is substitute in V squared over R squared. Okay. Let's say that you have a cylinder that's going to roll down a hill.
Oh God.
Not slide, roll. So what's the only type of energy that it has up here?
Potential.
Yes.
Now, if it rolls, how is that energy split?
Translational and rotational.
Yes, so that UG has to equal KR plus KT. So you're going to have MGH equaling 1/2 I omega squared plus 1/2 M V squared. Now, here's what you don't do. Okay? Here's what you don't do. Don't sit here and go, oh, let's say that this has a height of 0.1 meters, and you go, oh, I'll go old school, V squared equals V naught squared plus 2AX, so my initial velocity is 0. I know it's going to fall 0.1 meters. I can get my velocity, slam that in there, and then I can come over here. Oh, that's V squared over R squared. I can get that same velocity in there. Don't do that. Why?
Because they're not the same.
That's not the right number to use.
Because this, you can do that if all of your potential changes all into translational kinetic. Okay? It's not. It's splitting this thing. So what you have to do here, you do have to do this substitution, okay? And let's say that it's a thin hoop just to make the math easy, so that's MR squared. So I got 1/2 MR squared plus 1/2 MV squared. And then that equals MGH. Now, conveniently, the masses will cancel out, okay? And that R is going to cancel out.
What about the V squared?
No, those. So, but here's the deal. If I cancel everything out, I've got GH equals 1/2 V squared plus 1/2 V squared. So MGH just equals what? What's 1/2
V
v
squared.
squared plus 1/2 v
V
squared?
Two V's.
Dude, you don't know simple earth?
And again, I go back to the initial statement. We're gonna give you a diploma.
I thought they canceled
They have computers to do this
I
stuff now.
thought they cancel out, so I choose
Look at that, hey, look at that.
They call it calculus.
So if I give you $2.50, they cancel out.
Okay, that is.
No, it's the exact same thing.
That is not the same.
Sure it is. This is 1/2 plus 1/2. If I give you $2.50 by your math, I give you $2. I like this.
You multiply them. Oh, yeah.
You're adding them, Hunter?
If you're multiplying them, you'd only get a quarter.
Yes.
Obviously.
So 1/2 plus 1/2 is,
Yeah.
I assume they can't.
Oh gosh.
Well, that's what you get for assuming.
Ooh, there it is. Should I just
You're just stressing me out.
okay, you're stressing me out? No. Now, don't look at this and go, oh, this is how we work every problem. V squared equals GH. No. This just because it's MR squared because it's a thin hoop. If it's a hollow cylinder, you got to put in whatever the moment of inertia is for a hollow cylinder. If it's a solid cylinder, it's going to be completely different. So, but what is going to be the same in all of these processes is what you put in here, okay? The only thing that changes is what you put in here for the moment of inertia. Everything else in this process stays the same, okay? You will always get rid of your masses. Your radius is going to cancel out. The only thing that changes is what you put here. So you might end up with 4/3 or 1/2 or whatever it is when you get out of this, okay? So don't look at this and go, oh, I'll just memorize this.
So the equation will always be GH equals something V squared.
Yes.
But if it's a thin hoop, that's always gonna be the.
Yeah,
Okay.
that is true. If it's a thin hoop, but what do you, but I promise you, it's not gonna be a thin hoop on the test.
It's
Oh,
Yay.
why? Why?
Because I'm a jerk.
That would be too easy.
I know. Okay,
Look, thumbnail.
let's say that you have a pendulum
Just one thin hoop.
that swings down. And again, if you need this equation, I will give you this equation on the test. That y equals L times 1 minus cosine theta. Okay? You use this with the big pendulum problem where it came down, hit the two, and then they moved off together. Okay? So remember, this is going to be the angle, right? So let's play the what if game. What's the cosine of 0?
1.
1. So if it's straight down, cosine of 0 is 1. Right?
Minus 1 equals.
0, so it has no height.
Yes.
Oh, wow.
Whoa.
Math.
I speak the truth.
Thumbnail.
Okay, so obviously as the angle gets bigger, what happens to the height?
It increases.
It gets bigger. Okay? So as the height gets bigger, what's going to happen to the kinetic energy when it gets down here? It's going to get bigger, right? Yeah, yeah, because if you want to use a wrecking ball,
Should we pause it? No.
Yeah, but watch this. Sorry.
Because if you want to. Oh!
I know, bro. This is way too long.
That would take a lot of time.
okay, I'll make it happen.
No, I shall not go.
Okay. Yeah, so if you want to use a wrecking ball and you want to knock down a building, you want this to swing up higher because then it has more and more kinetic energy when it comes down here.
How
Okay,
does it swing higher?
so, but remember, what determines this kinetic energy is only this height. The path doesn't make any difference, okay? So if I let it swing or if I let it fall straight down, it ends up with the same kinetic energy. But is the time the same? If I let this thing swing out here and come down like that, is that going to take the same amount of time as if I just drop it straight down? No, this is going to take a lot longer, but I'm going to end up with the same kinetic energy because I only start with a certain amount of potential energy up here.
Your
that
velocity will
from
be
the-
the same though, right?
Yes.
Is that from the same height? If you drop it from the same
Yeah,
height?
if I drop it and let it fall this way or let it swing on a pendulum, because I only start with a certain amount of potential energy, it has to end up with the same amount of kinetic energy here. The only difference is the path that it takes.
But they have to be the same height
Yes,
to get this.
they have to be the same. Okay?
Okay.
Just like if I take a block and let it slide down versus dropping it straight down, this is going to take longer, but it's going to end up with the same velocity here as if this one just goes straight down.
Okay.
Okay?
Alright, so
Good.
times different, velocity same. Because same potential energy.
Yes.
That's pretty good.
Okay. Thermal stuff. Okay? Make sure that you understand what stays constant and what changes as you go through a pressure volume graph.
Don't know that.
This was a hard chapter. This is
Yeah, this is honestly
this
just
is
like
like
the
two
cherry
different
on top to this entire semester.
It's like
This whole
5
class.
different topics into one thing.
And it's just bleh.
Welcome to life.
honestly.
No, this isn't life. It's not life.
So this is
garbage man, I don't know.
No garbage man
garbage
needs to
man.
know
Get some
PV
So-
equals nerd.
Let's say I have a gas that I'm going to take it from this point to this point. Isobaric, isovolumetric, isothermal.
Isometric.
Isometric. So make sure that you understand thoroughly all three cycles on a pressure volume graph. So this is isovolumetric. So here's the deal. So what's happening in this syringe is that I'm keeping the volume constant. So if I go from this point to this point, and this is a situation, think this through. I'm going from here to here, right? I'm not changing the volume. What's happening to the pressure?
Increasing.
It's increasing. Am I going to make the stuff inside hotter or colder?
Higher.
Hotter. I'm going to give it more kinetic energy, okay? I'm going to give the second graders a bag of Skittles, right? But I'm not going to change the volume of the room. So what's going to happen to the pressure on the walls? Yeah, so this is Skittles with the same size room. Okay? So if you want to think of it that way, this is Skittles, all right, given to the kids, but we're not going to change the room. Okay? So we're going to give the kids Skittles, not going to change the temperature of the room, the pressure is going to go up. If you like equations, what's happening to the volume? Nothing. What's happening to N? Nothing. What's happening to R? Nothing. So as the pressure goes up, temperature has to go up. Is there any work being done?
No,
Why?
because there's no area.
Yeah, there's no change in volume, right? There's no force exerted through a disc. Get your foot off my table.
Really, Grant? Really, Grant?
That all-
Really?
The signs of disrespect. Just your generation, man.
Your generation and all their technology.
This
Okay, look, Captain Half. Okay.
half times a half is
A fourth.
ooh
Okay,
added by 4.
now,
4.5.
4 to 4. You added 4 to
delta U equals two things. What does it equal?
J plus W.
How about Q plus W?
What's J?
Joules.
Where did you get
They're both in joules, Flash.
Well, technically, he's correct.
Okay, but then it would be J plus J. Oh, what's J plus J?
They cancel out.
Another one! Number two.
Changing U equals nothing.
I'm gonna make a little table.
Or it'd be 1 because they cancel.
This is a good
What
one.
does delta U also equal?
The amount of energy brought in or total
How about-
energy.
How about 3 halves NR delta T? How about let's go
Hunter,
with
you were
that?
close. Only a couple numbers off.
Sure, it's all good. Equations, we don't need no thinking equations.
Wait, are those on the big dog?
Yes.
Okay, cool beans.
So, but here's the deal. So, if I look at this, what's the value of work? There is none, it's 0. So, the energy that I dump in all goes to increase the change in temperature. Okay? Right? Because W is going to be 0. Now, I get it to this point, and then I want to bring it across like this. This line is going to be isobaric. Okay? Is work going to be done?
Yes.
It will be.
Is work going to be positive or is work going to be negative?
Negative.
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 It's positive because volume
Because
volume is
smaller.
getting smaller, so it's positive. It's positive.
It's positive.
Yes,
You're positive.
I'm positive.
You're positive, it's positive.
I'm positive that it's
So 2
positive.
positives make a positive.
Negative.
Yes.
Okay? Now, in this situation, can I use work equal with negative P delta V? Yes.
Yeah.
Because I have a constant pressure, right? Because it's isobaric. Now, my final volume is less than my initial volume.
Two
So this
negatives.
is getting smaller, right? Okay? So basically, what happened here, I took the syringe and I heated it up, right? Dumped energy into it. That energy went to increase the pressure because the temperature went up. Now, as I go across like this, what am I going to do to the syringe? I'm going to make the volume smaller, right? So here's the deal. If work is done on the gas and you compress it, work is always going to be positive. If the volume gets bigger, that means that the gas is taking thermal energy and it's making stuff bigger, so it costed energy, which is why when you pucker your lips and blow on your hand, it feels cool because you're doing work, it goes past your lips, it expands, it cools down. Okay? Now, the other way that you can show this, so let's say I take this funnel. So here's the question. Here's the question. Can I make this ping pong ball stay up here, by blowing through the funnel?
No.
No. Okay.
You're a magician.
Did you blow into the funnel?
Yes.
That's what. I don't know that science. That's not my
Sure you do. Now,
Sorry.
look what happened on the inside of the funnel.
It got
There was
all
some
warm.
condensation, right?
Yeah.
Because as the air hit that expansion, what did it do? It expanded and it cooled down because it lost energy to expand. So the gas cooled down. That's why it condensed on the outside. Now, the reason that it works is because basically it's the same reason how an airplane wing works. Faster stuff goes, the lower the pressure is. So when I'm blowing through this thing, because if I don't blow fast enough, okay, I just blow it out. But if I'm going fast enough, the air creates a low pressure system on the bottom side that's enough to overcome the gravity, and it holds it up there. Okay? So if I do this, right, it'll stay up there because basically that air is moving so fast it creates a low pressure system that's enough to overcome the gravitational pull. Now I couldn't do that with a ping pong or with a golf ball, but I can do it with a ping pong ball. Okay? So, but what happens is on the inside of this, you see moisture condensing because that air, as it goes through that expansion, cools because it loses energy because it's pushing against the atmosphere that's holding it in. So what's happening here is that I'm reversing this. I'm making that volume smaller. Now, what's gonna happen to the temperature as I go across here? Well, look at this. Okay?
I think if you're making the
Hold on.
volume smaller, it should increase.
PV equals nerd, right?
That pin is not working.
Why no? I just put in new batteries.
What's wrong?
Do you have to like calibrate it?
No. Yeah, you can do that, but that isn't, I mean, it's right
It's just
where,
the equation, and you take like.
okay. So as I go across, what's happening to the pressure?
Stay the same.
Staying the same.
Pressure staying the same.
Volume is decreasing.
Volume is getting
Smaller.
smaller. So therefore, the temperature has to
Decrease.
decrease. So basically what has to happen here, okay, is that the temperature has to drop. So if you go to this equation, the temperature has to drop. So what's going to be the sign of my change in temperature? It's
Negative.
going to be negative. Therefore, my delta U is going to be
Negative.
negative. But my work is positive. So therefore, Q has to be
Negative and larger.
and larger than
That doesn't make sense. Volume decreases. I think the temperature should increase.
No, no, no.
If the pressure.
No. Visualize this, okay? I take this syringe, okay, and the whole key to this is that I can make, this plunger can move.
Right, and the pressure stays the same.
Pressure stays the same. So I put this into an ice bath, right? Energy is gonna flow out. So so the particles can't push against the plunger as hard. So you still have the same pressure on the outside pushing it in. So therefore, as I cool this down, that volume is going to shrink. Same thing happens with your car tires. When it gets really, really cold, what do you think is going to happen to the volume of your car tires?
Volume is getting smaller.
Yeah, because of the fact that the atmospheric pressure is still pushing on your tires, but the inside of the tires don't have as much kinetic energy, so the volume is going to be a little bit
Drove in the
smaller.
parking lot.
Okay?
Like the
All right.
the parking lot was open. Like
Now,
the first ones. in the
let's
row.
say that I
And
take
literally
this
went.
line
"This is
back
my
like
day.
this.
This is a good day."
When you have a curved line, what do you have?
Isothermal.
Isothermal. If I have isothermal, what's my value of delta U? What?
0 joules.
0. Because there's no change in temperature. So therefore, Q and W have to be equal and opposite. So in this case, as I go across, how can I find this area? There's only one way you can do it. That's where you got to use that natural log. Okay? I won't expect you to do this on the test. I just want you to understand the concept. Okay? So, but the math is simple. It's just natural log of VI over VF. But here's the deal. As I go across, here's what you do have to know. Is this work going like this going to be a positive or negative number?
Negative.
Why?
Because the
Because
volume
the
is
volume is
Yes.
increasing.
So the volume's getting bigger, so it's costing this thing energy because it has to push against the pressure that's trying to hold it down. So if delta U in this case is going to be 0, Q and W have to be equal and opposite. So what's happening is that I'm dumping energy into the system, but all that's being used to do work. So upon my passing, I'm going to leave Kendra $10,000.
I love this story.
But
leaving Kendra money.
I know, it's awesome.
I think she'd be responsible enough to do
Ha! Take
Are you
that.
kidding that? It's a
Hurts my
negative
feelings
6.
a little bit.
I didn't say you're not.
don't
I'm
think
just giving Kendra as an example.
Say my name.
No, it's always me. I always get it.
Look,
Just say everyone.
you can't take a half plus a half. I'm going to trust you with $10,000.
I'm a good money
He's lost
man.
10,000.
I manage my money well, so.
Well, yeah, now I know why you manage it well.
It's like, giving me 10, but
Well,
I
it wouldn't have been so bad if you had kind of said it quietly, but you just said it with such
confidence.
confidence, you know? And then you kind of had like this snotty attitude that, well, of course everybody knows that. That's what made it funny.
Right.
And then you even gave like a justification for it.
My hands are getting warm from the roast.
Okay,
Back to the money.
back to the money.
Kendra wants to go back to
All
the
these
story.
Kendra, big money.
Say Maddie, honestly,
Okay.
if we're being honest, we're giving the 10,000.
Why can't I have the money? I have the money.
She's been doing this video recording.
I've got the money like all 5 times we
Yeah,
brought
are you
this
gonna
up.
bring like Maddie a
See, I
bucket?
think I should get it. I only have negative
M&Ms
6
at the
cents in my
end of
bank
the-
account.
on Friday. Because Maddie's got a big job.
She does. and she's
And she
handling
doesn't
it well.
complain about it.
I know.
Have
Like
you missed a day?
I don't think so.
Never.
She has been here recording day in, day out.
I think we should have a little meet the Maddie
That's
section.
why when she walked in the very first day, I said, "You're going to sit right there and you're going to do the recording."
Did you know her prior to this?
Yeah, she was in my encore.
So you know she's.
I was late the very first day.
Yes.
Yeah, remember?
So, okay.
You've given her
Anyway.
the Wendy's,
Yeah, I was
like little slips of paper that say you.
A good 5
you get
minutes.
a plane.
Attendance things.
So what do you think? What did you think
Okay.
of Sharks when he walked in? I mean Kyle, not Sharks.
No.
Or you?
No, you didn't really think of us until the first day when we were sitting at the lab table.
Yeah, well, you had Garfield. Okay,
Because he wore a
matching
pizza
shirts.
shirt.
I gotta admit, I'm going, oh dear Lord.
I'm wearing those on the last day.
Okay, start with it, finish with it. Okay.
Hold on, you gotta wear an ugly Christmas sweater over it.
No, you don't.
Yes, you do, because it's ugly
Okay,
Christmas sweaters.
so anyway, if there's anything,
What if I want one?
It's all about the Cody points.
listen to me. If there's anything that you sit down and you think your way through, it's this process. I promise you, there's going to be a lot of questions on this. Isovolumetric, isothermal, the whole thing.
I always think I understand it until you just get to the test and you throw in a whole nother loophole.
Hey, is this
Okay.
video gonna be uploaded tonight so I can use this to
Yes.
study?
It'll be later, but it'll be up. It might be 7 or 8 by the time I get it up.
Oh, that's not late at all.
Late?
That's like,
No, because, okay, I have to be here to upload it at the end.
So you're gonna stay here till 8 o'clock tonight?
No, I'll go out and get something to eat, but I'll come back to make sure.
why?
that it's
What do you do?
I honestly
Why?
don't want you to do that. You go.
Go home.
No, it's okay. I don't have a life. All right.
Just do it.
Wait, why can't you upload
Watch
it
the
at
Chiefs
home?
game.
Yeah.
Because it has to upload through that computer, and that's where everything is saved.
Honestly, we're all gonna chip in, get you cheese
Just bring the
tickets.
computer.
I don't
home.
want Chiefs to.
Good.
Bring
No, I
the
don't.
computer home.
We're getting them for you.
We're gonna get you box seats.
Yes.
That's just how much of a nice class. No, we're gonna get you tickets to the game.
Oh, yeah. The
K-State games are really
The bowl
fun.
game.
Yeah,
No,
K-State
no,
bowl
I
game.
can't go.
Yes, you can.
No,
You don't even know what it
No, I
is.
can't.
Why?
Because the Monday after we get done, I'm having hernia surgery, and there's no way that I can travel.
You're having surgery?
So,
Ooh, can we talk about this surgery?
Then we're gonna bring the K-State bowl
Dr.
game to
Beasley
you,
is doing
Mercant. Where are you gonna be?
Oh, gosh.
Where are you gonna
Business
be?
class is
Coming.
bringing the K-State bowl game to you.
Can you imagine just being in the hospital and
Okay.
Eric and Kyle show up?
oh my God, security, I'm pressing the red button.
Can we all come in and visit?
Shooting up out of the thing like.
His heart rate. There you go.
And then like Reese would come in.
Okay, so stop that, let's go to the back.
16.
So right now, the reading on the scale is 169.01 grams, okay? So we'll take the ping pong ball, which is going to float. It's not going to actually touch the bottom of the glass, and I'm going to put that in the water. What's going to happen to the reading on the scale? Increase, decrease, or stay the same? The ping pong ball will float in the water. Increase, decrease, or stay the same?
Say it again.
Okay, I'm going to take this ping pong ball, and I'm going to put it in the water when it's going to float,
Pong ball will weigh less.
okay?
Yeah, it's gonna weigh less.
Decrease.
So, here's my question.
Weighs less.
The reading on the scale right now is 169.00 grams. So here's the question. Once I put the ping pong ball in, okay? Once I put the ping pong ball in, will the reading on the scale increase, maybe go up to like 171, decrease, go down to like 167, or it'll just stay the same because the ping pong ball is neutral? Quit!
Increase.
That logical answer.
You're adding
Logical
math.
answer.
You're adding math.
It's gonna stay the same.
It's going to increase.
Mr. Rollins?
It's not.
Explain that there's like going to be a giant hippopotamus that pops out or something like that.
I'll never know.
I'm adding something to it.
But I don't think increase. Nothing in here is logical.
Okay, how many vote that the reading on the scale is going to increase?
I definitely say it's
Not you in research.
Okay.
Voting president, top
Okay,
president.
so how many say it's gonna stay the same?
Science.
Right here.
Okay, how many vote it's actually gonna decrease? One.
Matt, is there
You're-
anything
you
special
felt-
about the water?
I
You're-
have no idea. It's gonna be right.
It's gonna do what?
I'll be witness to this.
Okay, you ready?
He's adding it, and it increases, of course.
Goes up to about 172.
Science makes sense
It
again.
was just like. It only took 18 weeks for a logical answer to happen.
Okay?
Only took
Finally, 18 weeks, you finally got a logical answer. Why? Why did it go up? I added mass to it. Okay?
Gosh,
Why
that
don't we
makes
use
sense.
triple beam balances anymore?
Feels so good
Okay.
about myself.
Now, what if I did this? So it's basically, it's Newton's third law, right? Things have to balance out. So the water has to provide an upward force, right? That buoyant force, so the scale then is going to reflect that by having a greater value. So what I'm going to do this, I'm going to take a mass and I'm going to suspend it in the water, but I'm still going to have the scale going up. Okay? So now, what's going to happen to the reading on the scale? Because this one I'm going to have it suspended. I'm not going to have it floating. This one I'm going to have it tied to a string. And then I'm going to lower it part way into the water, but it's not going to touch the bottom. Stay the same.
Decrease. Put it in there.
So you think this number is going to go down?
Yep, 68.9.
Okay?
And it's gonna go into the water?
Yes. But not all the way to the bottom.
Yeah, it's not gonna touch it though.
Okay? It's not going to touch anything on there. And I'm not going to let it touch the
So
bottom.
Shards, how would that decrease?
I'll show you how.
Oh, I thought you meant like it wasn't even gonna touch the water.
See?
What do you mean, see?
Well, I just wanna check
What are we looking at?
So, we're up to about 175.
That's an increase.
That's an increase.
Yep. Yeah.
So, why did the reading go up again?
Because they're still buoyant.
Yeah, it's still the exact same idea. It's still Newton's third law. So the buoyant force is acting up, right? But Newton's third law says there is an equal and opposite force acting on it. So there's an upward force acting up, but that's also pushing down. That's why the reading on the scale goes up. Now, if I take it and let it obviously rest all the way down to the bottom, okay, then it goes up by quite a bit because then it's carrying the entire load of the weight. Got it? Good? Water completely filled to the brim. Completely filled. Okay? Completely filled to the brim. And then I'm going to put some ice cubes in it. Okay? So that part of the ice cube, they're going to float, right? But the water is still completely filled up to the brim.
It will stay at the ground.
So as the ice melts, what's going to happen to the water level?
Wait, so
It's gonna spill.
is that the brim when you
It
put
will
the ice
stay
cubes
the
in?
same.
Yes, it's
It's
already
taking up
at
the
the
same
brim.
amount.
And then you
I
add
put
ice
some ice cubes in, it overflows some so that we know it remains
It,
completely full.
it
Okay.
remains
So
completely full.
the
with
ice cube's
in
gonna
it.
be floating, okay?
It's gonna melt. It's
Oh.
gonna
So as it
Water
melts,
level's
Take
gonna
up
go
the same
down.
amount of volume.
Which is denser, ice or
yes. So what's gonna happen to the water level?
Down.
Stay.
It's gonna spill.
Stay the same, why?
Now you're taking up the same volume.
Yeah, you've already displaced a volume equal to the weight of the ice cubes. Okay? Now, I'm going to caution you about this. And here's the reason why people say they're talking about global warming and they're going, well, hey, if the ice melts, it's just like this situation. Okay, hey, the ice is already in the water. If it melts, it's not a big deal. But here's the problem. That we're not, if you talk about global warming in a worst case scenario, you're not melting ice that's already in the ocean. You're melting ice that was on Greenland and Iceland and the entire continent of Antarctica. So you're not melting ice that's already in the ocean. You're melting ice that's on land. So that's the concern as far as the ocean's rising, is that, yeah, if we just melt the ice that's in the ocean, they're right. The water levels aren't going to go up. But that's not what you're talking about melting. You're talking about melting entire ice sheets that are on land. Then all that water goes into the ocean, then the water levels go up. So if you're into an argument and someone says, oh, the ice is already in the oceans, that's not what we're talking about melting in a flash. So, bless you. Okay, so for the review, if this gives you some idea as far as what, bless you.
I'm sorry, that's my last one.
Okay. There's two distinct parts to the review. There's the energy part and then there's the thermal part.
What the heck?
The thermal part, question number
He
2,
says that with a
goes
smile
all
on
the
his
way
face.
through O.
That is a.
On the review?
Okay?
Is there a
Yes.
back page to that? A back
Huh? No, there's just front sides
Oh,
to both.
good.
But then you also have the
Is that like
complete
13 parts?
review answer key to it. So there's gonna be 2 parts to it. Shut her down, we're done.